Welcome to this video on energy costs. The aims of this video are to find out more about how we pay for domestic electricity, so electricity in the home, and how electricity is generated by a variety of means. But first of all, let's look at the energy we consume. Our food labels list the energy of content in food in the unit of kilojoules. And you can see some examples here where they've given different food products and how much energy they contain. Now 1 kilojoule is equal to 1000 joules, and sometimes as scientists we need to be able to convert between those two. So what does it mean that we've got 435 kilojoules? Well, that means it's 435,000 joules of energy. So how much energy do we use when we're working out or doing different activities? Here are some examples of different activities, and they show us for 30 minutes for a 60 kilogram person. If you're doing your exercise for longer, you're going to be using more energy. If you're a heavier person, you're also going to be using more energy. Now, our electric bills. We use electric meters to measure how much electricity our houses use, and that information then gets sent to our electricity companies, who send us back a bill. And there you can see on the bill it shows two readings, which are how much electricity the meter has read at different times, and then we can work out the difference, how much we've used in that time, and therefore the cost. So to work out how much we need to pay, we need to take the meter reading at the end of the month or at the end of the period that we're looking at. So for example, my meter reading could be 43,578 at the end of the month. At the beginning of the month, it might have been, well, it would have been a lower number. So we'll give an example number here of 43,495. So to work out how much electricity we've used in that time, we just need to subtract the start value from the end value. So doing a little bit of subtraction, we get that it is 83 kilowatt hours. So the units that we measure our domestic electricity in are kilowatt hours. So then how much is that going to cost us? Well, our bill tells us something called the cost per kilowatt hour. And usually at the moment that's around 14 pence. So we'll say 14 pence per kilowatt hour. So that gives us a total cost of 83 times 14, which is £11,062 or £11.62. We can also work out the cost of using individual appliances. So if I was to say take a hairdryer, hairdryer might have a power consumption of 2 kilowatts. And I'd probably spend about half an hour drying my hair. So if I run a 2 kilowatt hairdryer for 30 minutes, and the cost of electricity is 14p per kilowatt hour, I can use this equation. Cost equals power times time times price per kilowatt hour. So I need to do the sum. Cost equals 2 times a half, or 0.5, times 14. And that gives me an answer of 14p. If we go through another example, if I run a 500 watt freezer and I run that for 24 hours, again we'll take the cost of electricity to be 14 pence per kilowatt hour. So this time we need to convert from watts to kilowatts. So 500 watts is half of a kilowatt, so it's 0.5 times 24 times 14, and that gives us a total of £288 or £2.88. Let's have a look at some other appliances, because you guys need to be able to compare the different energy uses. So a TV has very low energy consumption. It uses only 36 watts. So we might run a TV for 3 hours a day. So to work out the cost for that, it would be 0.036 times 3 times our 14p per kilowatt hour, which would give us a cost of only £1.5p. If we take another example with a hairdryer, 2 kilowatt hairdryer, run for only 20 minutes. So that would be a third of an hour. So to work out the cost, we do 2 times a third, or 0.33, times 14. And that gives us a cost for running our hairdryer of £9.3p. So much better to watch the TV, much less expensive. Right, so how do we generate our electricity? Well, you can see here how our electricity generation has changed. The green section that's gone up quite a lot over the last 10 years or so is renewable power. So that includes solar, wind power, tidal power, wave power, hydroelectric power, and geothermal power. Okay, so renewables are things that won't run out. So you need to be able to explain the advantages and disadvantages of each of them and show the energy transfers. So let's start with fossil fuels. Fossil fuels are a store of chemical energy which gets released when we burn them. So the chemical energy gets turned into thermal energy. We take that heat energy and heat water with it, and the water turns into steam, which moves through a turbine and turns the turbine, so it produces kinetic energy. The turbine then turns a generator, which generates electrical energy. And at each stage, there's some waste energy as thermal energy. Now, what's good about burning fossil fuels? Why do we do it? Why is this still our main form of energy? Well, it's really reliable. We know that we could burn our fossil fuels at any time. It produces a large amount of electricity. And we can build a fossil fuel power station pretty much anywhere. Now, the disadvantages are that it is going to run out one day. Okay, so the prices go up as the amount of fossil fuel goes down. It produces pollutant gases like carbon dioxide, which causes the greenhouse effect, and sulfur dioxide, which causes acid rain. And the fuel can be quite expensive, particularly, as I said, as we get closer to it running out. Nuclear power is an alternative. Nuclear power uses uranium or plutonium, which releases energy through a nuclear reaction. That releases heat again, so thermal energy, which again is used to heat water that turns a turbine, creating kinetic energy, which then turns a generator, which generates electricity. And like with fossil fuels, there is waste heat energy at each step of the process. So the good things about nuclear power are that it produces loads of electricity. For a kilogram of fuel, it produces thousands of times more electricity than coal, oil, or gas does. It doesn't produce any pollutant gases, so none of that nasty carbon dioxide or sulfur dioxide. And it's not going to run out for a very long time. We've got a very large supply compared to how much is actually needed at any given time. Disadvantages? Well, the main one is radioactive waste, which can be quite dangerous to animals. It can cause cancers because it gives off radioactivity. It's also very difficult to store. It's expensive to set up a nuclear power station, and it's very expensive to do what we call decommission it, so break it down at the end of its life, because a lot of the building materials have become radioactive. Solar power is the first of our renewables. So very simple. We take the light energy from the sun and it gets converted directly into electrical energy. Again, some thermal energy is released in the process. So what are the advantages of solar power? There's no pollutant gases. It's a free energy source. We don't have to pay anything for sunlight. And it's renewable. It's not going to run out. Disadvantages, though. It's unreliable, particularly in countries like Britain. We don't always have sunshine. It produces a relatively small amount of energy. You need very large solar panels in order to create a large amount of electricity. Wind power. So wind power takes the kinetic energy, the motion of the wind, and uses that to turn a turbine, which turns a generator, which creates electrical energy. And of course releases some waste energy as heat. The advantages of using wind power, as with solar power, it's renewable. There's no pollutant gases. And it's a free energy source. The disadvantages, well, it's considered to be unsightly. Often people complain about the wind turbines spoiling the views of the countryside. The wind turbines can also be fairly noisy if you go near them. It's unreliable. It depends on there being wind there. And again, it produces a fairly small amount of electricity, so you need a lot of wind turbines to get the amount of electricity that we need. Hydroelectric power relies on water flowing downhill. So it starts with gravitational potential energy. The water's raised up. As it flows downhill, that turns into kinetic energy, which turns a turbine. The turbine is connected to a generator. The generator creates electrical energy. And again, we've got waste energy as heat. The advantages of hydroelectric power will be becoming familiar to you. There's no pollutant gases. It's renewable. This one is really reliable as well. And water is a free energy resource. Disadvantages are that there are large amounts of flooding produced. You have to build a dam across a river in order to get hydroelectric power, and that can cause large flooding areas which damages the habitats of the plants and animals that are living nearby. Tidal power uses the kinetic energy of the water in the tides, converts that through a turbine and generator into electrical energy. Now, tides are powered by the moon. So the moon's energy goes into them. So they're really reliable. As long as the moon is going around the Earth, we're going to get tidal power. It's renewable and there's no pollutant gases. However, because we only get 2 tides a day, it's not a constant supply of energy. It's only useful for short periods. So you'd have to find a way of storing the electricity. Okay, there will be some damage to the environment where it's built as well. Wave power uses the energy from the waves. So again, it's kinetic energy that's being converted into electrical energy and waste of thermal energy. Our advantages again, there are no pollutant gases produced. It's renewable. And there is low cost because the waves don't cost any money. Disadvantages to wave power though. Because waves are produced by the wind, that makes it unreliable. There's not always going to be waves there. And the other problem is, if it gets too stormy, it can be easily damaged. Okay, the wave power turbines can get pushed up against the coast and damaged by storms. Geothermal power is our last power source, and this uses radioactive rocks under the ground to produce heat Water's pumped down into those rocks, so they get heated up. That goes back up to the surface, where it turns a turbine with kinetic energy, which turns a generator to generate electricity. The advantages of using geothermal power: it's really reliable because those rocks are going to be staying hot for a very long time. It's renewable. There are no pollutant gases produced. And the energy itself, once it's been set up, is quite cheap. However, the disadvantages: it's really expensive to get it set up in the first place because you have to drill down quite deep into the ground. And the other problem is that it's only available in certain places. So in this country, the best place to find those radioactive rocks under the ground is in Cornwall. Iceland relies very much on using geothermal energy as well, so they've got a great supply of it. But there are other parts of the world where you wouldn't be able to use geothermal power. Thank you for watching. To find out more, please look at the links below. Thank you.